Hi, in this video, I'm going to talk about the sampling distribution. So let me start with the concept a little quick. So we are interested in the population parameter. So here is a population. We want to know the population mean mu and population proportion pi. But in many cases, we cannot have the population data. So instead, we get the sample and we calculate sample statistic such as sample mean X bar and sample proportion P, okay? And once you get the sample, you want to infer the population parameters because that's the goal. We want to know the population mean mu and the population proportion pi. But since we cannot get the population data, we get the sample instead. And from the sample, we calculate the sample mean X bar and the sample proportion P. Okay, but you notice that when you get the sample, so first day you get the sample size n equals 30, and then you calculate the sample mean x1 bar. Let's say that the sample mean is a GPA for 30 students, and it turns out that their GPA is 3.64. The following day, you get another 30 sample, and you calculate the sample mean, it turns out to 3.58. So each day you get the sample, you will have a different sample, and that means that you're going to get the different sample means, right? So if you repeat this process, we're going to have the sampling distribution. So that's what we're going to talk about. So when you get the sample and you repeat this process, then you're going to have the sampling distribution. But there's a cool thing. That is a central limit theorem. So take a look at this definition of the central limit theorem. So regardless of the population distribution, even though it's not normal, as long as you have the largest sample, then it follows normal. So that means when you get the sample mean and the sample size is large enough, then it follows normal distribution with the mean equals mu of the X bar and the standard deviation is sigma of the X bar. When n is large enough, in general, you can say that n is greater than 30, then the sample mean will be approximately normal by the central limit theorem. And this mu of the X bar is same as a population mean mu. And this sigma of the X bar, we call it the standard error. That is same as sigma over square root n. But I'm going to skip the details about this formula. But let me give you the intuition of the mu of X bar is y is the same as a population mean mu. So here is a population. And then you get the sample, as many as possible, like this. And from each sample, you calculate the sample means. And when you have the lots of the sample, and it covers almost every population, the data, then it will be the same as a population mean. So like you get the sample mean x1 bar, I get the sample mean x2 bar, so on and so forth, and you have a large sample. And then you take the average, then it's going to be same as population mean. So average of the sample means is same as a population mean. That's why we denote the mu of the X bar equals a population mean. So that is an average of sample means. That equals population mean. Okay, that's about the population mean. Now we can do the same thing for the proportion, but proportion is a little bit different. Sample proportion follows normal distribution with the mean equals the mu of the P. That's the same as a population proportion pi. And then the standard error, sigma of the P, is the same as square root pi times 1 minus pi over the sample size n. But there is a condition. In order to use in order to have this sample proportion follows normal distribution, we need to have the condition that is following. N times pi is greater than or equal to 10. N times 1 minus pi is greater than or equal to 10. Then we can say that this sample proportion P follows approximately normal. Now I'm going to solve some questions. So take a look at the first example. According to a report from a business intelligence company, smartphone owners are using an average of the 23 apps per month. So let's say the number of the apps is equal to, we denote to X. And then that we assume that the number of the apps or user per month by smartphone owners is normally distributed. So that means the X follows normal with the mean equals 23 and the standard deviation is given as 7. Okay. Now, given this situation, take a look at the first question. If you select a random sample of the 36, that means n equals 36. What is the probability that the sample mean? So the question asks you about the sample mean. and which is between 22.5 and 23.5. So we want to find this one. Probability X bar is between the 22.5 and 23.5. And from the previous the page, we studied that X bar follows normal distribution with a mean equals 23. That's the same as a population mean. And then the standard error, sigma of the X bar is 7 over square root 36, okay? And once you do that, you can easily find this probability. Well, you can visualize to avoid the mistake. So this is an X bar, and this is a normal distribution. Why it follows normal distribution? First, the population distribution is normal. Second, the sample size is large enough, 36. Even though the population does not follow the normal distribution, because we have a larger sample, which is 36, we can say that this X bar follows normal distribution. So that's why the X bar follows normal distribution with a mean equals 23. And then we want to find this probability. So this is a 22.5, and here is 23.5. We want to find this green shaded area. So here's my plan. I'm going to find this yellow one. That is probability X bar is less than 23.5. So that's a yellow one. And then I'm going to find this blue one. So if once I find the yellow one and the blue one, then the difference between these two gives me the answer. So this blue one is a probability X bar is a less than 22.5. So that is here. So how can you find it? So using the Excel, the first one, norm dist 23.5, mean equals 23, and then the standard deviation is a 7 over square root 36 and 2. Then you get the first one, and the second one is the same, norm dist 22.5, mean equals 23, standard deviation is 7 over square root 36 and 2. So 2 means that you calculate from the negative infinite to 23.5, then you get this yellow one. And you put the 22.5, so here 22.5, mean equals 23, standard deviation is 7 over square root 36, and you say the 2, that means that from the negative infinite to the 22.5, you find this blue shaded area. So let me show you with the Excel. So take a look. So put the equality, norm dist here, 23.5, mean equals 23, standard deviation is a 7 over square root. Square root is a SQRT, 36. Actually, square root 36 is a just 6, so you can put the 6 instead of the square root 36, and then 2. Then I got 0.6659 up to 4 decimal places. So that is 0.6659 minus the second one. You do the same thing, but just replace it with the first one. Norm dist 22.5, mean equals 23, standard deviation is a 7 over 6, and then 2. Enter. So that is a 0.3341, 0.3341. So you just need to find the difference, but you don't need to calculate with the calculator, just using the Excel. First one, 0.6658, that is an A1 cell, minus second one, that's an A2 cell, then it gives the answer. The answer is a 0.3318, up to 4 decimal places, okay? Now let's solve the second question. If you select a random sample of the 100 smartphone owners, what is the probability that the sample mean is between 22.5 and 23.5? Everything is the same except for the sample size. Now the sample size becomes n equals 100, but then the questions are totally the same. Then you just need to do this one. You calculate these things. So let me copy and paste. So exactly the same question except for the sample size. So take a look. I'm going to change the sample size from the 36 to those 100. So the denominator of the standard deviation becomes square root 100. That is actually the just 10, right? Then let me show you. Let's reuse the Excel that we put before. So from here, let me just change the square root 36 to 100. And then the second one, 7 over square root 100 is just 10. So 6, let me change the 6 to 10, enter. Then we get the answer. The first one is a 0.7625 up to 4 decimal places. The second one is a 0.2375. And then the difference is going to be 0.5249. Okay, that's the answer. When you have a large sample, sampling variability becomes smaller, right? Because as you can see, the formula, sigma standard error, sigma of the x bar is a sigma over square root n. So n becomes large, then this standard error goes down, okay? Now let me solve the sample question. Take a look. Full-time college students reports spending a mean of 26 hours per week on academic activities, both inside and outside the classroom. So let me denote the x is the amount of time they spend, and it follows normal distribution. Oh no, we don't know that whether it follows normal distribution or not, but we know that mu of the x, that is just population mean, which is known as 26, and the standard deviation sigma is known as 5. Now take a look at question number A. If you select a random sample of the 49 full-time college students, that means that you get the sample n equals 49. What is the probability that the sample mean? So here, the mean time spent on the academic activities. So that is a sample mean, okay? So actually, it's missing here, sample mean, okay? So I can denote this way. We want to find the probability x bar is less than 25, okay? In order to find this answer, we need to know the distribution of the x bar. But like I told you, we don't know the population distribution, but we know the central limit theorem. So by the central limit theorem, we get to know x bar follows normal distribution with the mean equals mu of the x bar, and then standard errors, or this sigma of the x bar. Here, this one is same as a population mean, which is known as a 26, and sigma of the x bar is a sigma over square root n, okay? In this case, 5 over square root 49. Now, then this one becomes very easy. So norm dist 25, mean equals 26, and standard deviation is 5 over square root 49, and true. Then you can find the answer. Or you can visualize it, because if you think that this is a little bit tricky, then I recommend you to draw the graph to make it sure. So here's the x bar, and the x bar follows normal distribution by the central limit theorem, and the mean equals 26. And we want to find this probability, this green one, okay? And this is exactly the same, this one. Now, using the Excel, let me do the exactly same thing. So put the equality, norm dist 25, that's the first one. That is x value, x bar value, and then mean equals 26. Standard deviation is 5 over square root 49, that is just 7. And then true. Enter. So it turns out this green shaded area is a 0.0808 up to 4 decimal places. That's the answer. Now let's go to the second question, B. If you select a random sample of the 49 full-time college students, there is an 85 chance that the sample mean is less than how many hours per week? Oh, this is a different question. Now you know the percentage, but you want to know the x bar value. So you can visualize like this. So here's the x bar, the same graph. So here's a mean 26. Now there is an 85% chance that the sample mean is less than how many hours per week. So that being said, we want to find, so this is known as 85%, and you want to know that this value, okay? Now, what do you need to do? Well, this time you need to use a norm inverse. We know the probability, the percentage, but we want to find the x bar value. Now, what do you need to do? Norm inverse, you put the 0.85, mean equals, what was the mean? 26, and then the standard deviation is 5 over square root 49, then it gives you the answer. So let's do it. put the equality, norm inverse 0.85, so that's the 85%. And then mean equals 26, standard deviation is a 5/7. Then that is a 26.74. So this number is 26.74. Of course, that you can use a standard normal and the standard normal table, but here I'm trying to show you how to find the answer real quick by using the Excel. Okay? Now let's move on. The question number 3 is about the proportion. Now, take a look at the question. An institute reported that 64% of its members indicate that lack of the ethical culture within financial firms has contributed most to lack of the trust in the financial industry. Suppose that you select a sample of the 100 institute members. So we want to know whether the sample proportion P follows normal distribution or not. Well, like I told you, we need to check the condition. N times pi is greater than or equal to 10. N times 1 minus pi is greater than or equal to 10. Then we can say that this P follows normal distribution. So N is 100, and the proportion, population proportion, is known as a 0.64. Now, of course, that this is a 64 greater than 10, right? So first condition is satisfied. Second one is 100 times 1 minus 0.64. That's a 0.36. That's a 36, which is greater than 10. Then I can say T follows normal distribution, and the mean equals 0.64, and then the standard deviation, the formula is a square root 0.64 times 0.36 over the sample size. Again, here the standard error, sigma of the P is same as square root pi times 1 minus pi over N. So that's why I have the square root 0.64 times 0.36 over 100. Okay, then it becomes clear. Take a look at the first question A. We want to find the probability. The sample proportion P is between the 0.57 and 0.72. Okay. Again, you may want to draw the graph to avoid the mistake. So let me show you how to draw the graph. Okay. I need a space. So let me draw it here. This is a sample proportion P, and we know that that one follows normal distribution with the mean equals 0.64. And here is a 0.57, and here's a 0.72. We want to find the shaded area. Like we did it before, in order to find that green shaded area, we first need to find the probability sample proportion is less than 0.72 minus probability sample proportion is less than 0.57. So the first one, let me use the yellow color one. So this one is the first one. And then we need to find this pink one, okay? And then subtract, and we can find the green shaded areas. So let me find the yellow one first. So that is norm dist, because it follows normal distribution, 0.72, mean equals 0.64. Standard deviation is square root SQRT, 0.64 times 0.36 divided by 100. And then 2. So we just calculate from the negative infinite to the 0.72, given that mean equals 0.64, standard deviation, that is a square root thingy, then we can find that that is a 0.9522. So the first one is a 0.9522. And then let me find the second one too. So probability, the sample proportion is a less than 0.57. So norm dist 0.57, mean equals 0.64. Standard deviation is square root 0.64 times 0.36 divided by 100. And then the last element, we need to say the true. So that gives me the probability from the negative infinite to the 0.57. Enter, that is a 0.0724, up to 4 decimal places. So let me find the answer. So the first one, this 0.9522 minus the second one, 0.0723 something, that it gives me the 0.8798. That's the answer. Okay. Now, question number B. the probability is 60% that the sample percentage will be constrained within what symmetrical limits of the population percentage. All right, so the question asks you following. So here is the sample proportion, which is a normal distribution, which follows normal distribution with the mean equals 0.64. Now they let us know this shaded area, symmetric around this mean, and that's the 60%. And we want to know this value. Let me denote. This one is sample proportion P1, and this one is sample proportion P2. We want to know that one. But given that the normal distribution is symmetric, I also know that here, this shaded area is 20%. Why is it 20%? Well, 100 minus 60%, we have the 40%. And you divide by 2. Why do I need to divide by 2? Well, we have the left one and the right one. So the left one is a 20% and the right one is a 20%. Okay. Now we can find it. This P1 is same as norm inverse 0.2, that represents the 20%, and mean equals 0.64, and the standard deviation is square root 0.64 times 0.36 over over 100. So let me find it. So I can find the P1, sample proportion 1. So norm inverse 0.2, 20%, and mean is 0.64, and then the standard deviation is square root 0.64 times 0.36 over 100. Then I got the 0.5996. So this is a 0.5996. Okay. Likewise, you can find the P2, but be careful. This time, if you put the some long number, then you will get the different answer, wrong answer. So the question is, what do I need to put the first element? Like I told you, XR is calculating from the negative infinite to this number. So I need to put this 60% plus 20%, 80%. Then I will have this P2. Okay, so that's why I need to put 0.8. Again, the same mean is a 0.64. And then the standard deviation is a square root 0.64 times 0.36 over 100. Then that is 0.6804. So that is 0.6804 up to 4 decimal places. And you can actually find the difference between these two. So from here, 0.64 to the 0.5996, and that difference is exactly same as here. Again, because of their symmetry. So take a look. So you can check it by yourself. If you take a look at the difference between the 0.64 and the P1 and P2 and 0.64, they are equal. They have to be the same because it's symmetric. Okay. Now, one last question. Question number 4. So a political pollster is conducting an analysis of the sample result in order to make predictions on election night. Assuming a two-candidate election, you can think that that's the Biden and the Trump. If a specific candidate received at least 55% of the vote in the sample, the candidate will be forecast as a winner of the election. You will select the sample of the 100 voters. So we know that the sample size is 100, but we don't know the population proportion. But from the first question A, you get to know the population proportion is known as 59%. So in that case, you can check the n times pi and the n times 1 minus pi, but of course they are greater than 10 or equal to 10. Otherwise, we cannot go forward. So this condition is satisfied, and we can say that sample proportion P follows normal distribution with the mean equals 0.59. And then the standard, 0.59, and standard deviation is square root 0.59 times 0.41 divided by 100. Okay. Now, in order to become a winner, he or she needs to get at least 55%. That means we want to find this probability. Probability sample proportion is greater than 0.55. Okay. Again, you can visualize it. So this is a sample proportion distribution, which is normal. So mean is 0.59, and you want to find this one. the shaded area. So what I'm going to do is I'm going to find this purple shaded area. So the purple shaded area is following. Norm dist 0.55, mean equals 0.59. Standard deviation is a square root 0.59 times 0.41 divided by 102. Then it gives me the purple shaded area. In order to find the blue one is a 1 minus this purple one. Then I can find this blue shaded area. Okay, so let me find the purple one first. So norm dist x equals 0.55, mean is a 0.59, standard deviation is square root SQRT 0.59 times 0.41 divided by 102. Enter. Somewhere I made a mistake, so let me see. Let me check the error. So norm dist mean is the x is a 0.55. The second one mean is a 0.59. Here I had to divide it by 100, but I put the dot by accident. So here, remove the dot and divide it by 100. Then it gives me the answer, 0.2080. But students commonly make a mistake, they stop there. But we wanted to find this blue shaded area, right? So that means that 1 minus this number gives me the answer. So equality, put equality, 1 minus that number is a 0.79197. So that is 1 minus 0.2080 something is 0.79197. Okay. Of course, you can round it up to 4 decimal places, 0.7920. Okay. Now, the last question of today's lecture. So question number B. What is the probability that a candidate will be forecast as a winner when the population percentage of her vote is a 49%? Now everything is the same. So we have the n equals 100, but now the pi is known as a 0.49. Okay. And you can also check the condition, but here obviously n times pi is greater than 10, n times 1 minus pi is greater than 10. And we still want to find the probability sample proportion is greater than 0.55. Then this is exactly the same as 1 minus norm dist 0.55, mean equals 0.49, and then the standard deviation is square root 0.49 times 0.51 over 100 and true. Then you can find the answer. So let me do it real quick. So, but I'm going to put everything with a one cell. So 1 minus norm dist 0.55, mean equals 0.49, standard deviation is a square root 0.49 times 0.51 over square root over 100, right? And then you put the true because we need to find the probability, and then enter. So the answer is 0.1150. So what's the difference? The first one is a population proportion is known as 59%, but then the second question, population proportion is known as a 49%. Given this, you will have a different probability. The first one is a 79.2% probability that she is going to win. And then the second one, given that the population proportion is known as a 49%, the probability she wins this election is only the 11.50%.